So I want to go over an example of an ellipse problem. This is a little bit abstract. I'll talk more about applications of conic sections in a later video, but let's say that you're going to do that geometric construction and you have two pegs that you're going to stick down, and you're going to tie a rope to each peg, and you tie a string, one end of a string, and then you're going to do the whole tracing around business. Let's say that in our coordinate plane, we put the pegs, which would be the foci, at locations 2, 5, and 2, -3. Now the fact that these both have an x-coordinate 2 is actually sort of important. We are going to just talk about vertically oriented or horizontally oriented ellipses in this class. We're not going to get to the tilted ellipse or tilted, axis kind of stuff. That is in the textbook, but it uses trigonometry, and so we might get a chance to talk about it later, but not now. So these two pegs are going down on the same vertical line. I'm just going to plot where those points would be, and all I'm doing is plotting 2 points on a vertical line, and the 2, 5 would be the one on top, and the 2, -3 would be the one on the bottom. So that's where we're going to attach our string on two ends, and then the string's length is 10 whatevers, let's say centimeters or something. We've got to make sure that our grid system and our string length are being measured in the same unit. I'm not really specifying what that is, but so we're saying these D1 and this D2, whatever they are, will always add up to 10. Okay? So now the question is, given this information, let's find the equation of the ellipse. Find the equation. Well, first things first, the low-hanging fruit here would be the center point of the equation, because the center point is exactly halfway between the two foci, in the same way that it is exactly halfway between the two endpoints of the major axis. So the center point is going to be right here, halfway between, which means we should calculate what the halfway point would be. It's going to be on the same line, same vertical line, so 2 is going to be the x-coordinate, but the y-coordinate, halfway between 5 and -3, let's see, 5, 2, should be 1, right? 2, 1? Is that right? Because 5 plus 3 is 8, so it's a distance of 8. Divided by 2 is 4, which means this distance here is 4. And so 1 is 4 units from 5 and 4 units from -3. So there we go. So far we have the center location is going to be 2, 1. So we've got the HK. And the other piece of information we got from this is the C value. C equals 4, right? It's half that distance. Or in other words, the distance from the center to a focus. So there's some pretty low-hanging fruit. And there's another piece of low-hanging fruit, which would be the A value. I double-checked the textbook, by the way, and our textbook does use A as the half-length of the major axis. So in this case, with vertices on oriented along a vertical line, our ellipse is going to look something like that. It's going to be more of a vertically oriented ellipse, which means that distance is going to be A this time, and this distance is going to be B, right? So A and B, respectively, right? A is exactly half of the length of the string. That's what we found out in the last video, right? It's 2A is the length of the string. So if 2A equals 10, then we're going to get from that A equals 5. So we have our center, we have our C value, and we have our A value. Now, we're almost there, because to get the equation, remember, it's this. Let's write it out. All we need is to know the values of H and K and the values of A and B. We know H and K, we know A, now we just need to find B. And to find B, all we need to remember is that there's an algebraic relationship which came from the Pythagorean theorem between A, B, and C. It's not A squared plus B squared equals C squared, which is what you're used to seeing for the Pythagorean theorem. Things were a little bit different. Watch the last video and you will see we have C squared is A squared minus B squared for ellipses. So, given that information, we're going to have 4 squared is 5 squared minus b squared. So 16 is going to be 25 minus b squared. And from this, we can get b squared is going to be 25 minus 16, which is 9. So what is b? It's 3. Okay. We don't have to think about b equal -3 because b is a distance. A, b, and c are all distances, so we only care about the positive options. So when solving an equation like this, we do not have to bother even considering the -3 possibility. Okay. So there we go. We got all the information we need now. We figured out the coordinates of the center. We figured out the c value and a value, and then from that we found the b value. So we're not going to use the c value in the equation, but we'll use everything else. So now our equation is going to be x minus 2 squared. I pulled the 2 from here. Over. Now actually, I just realized that I messed this up. I made a mistake. Because, as I mentioned, the textbook takes the a value and assigns that to the half length of the major axis, which in this example is vertical, right? Like that's this distance. So actually, that is a scaling factor. You're stretching out your circle by that amount in the vertical direction. So really, we should be dividing the y term by a squared, okay? Because y is our vertical variable, right? So actually I had those backwards. Let me fix that for you. There we go, that's better. So now with the correct equation format, I've got x minus the 2 squared divided by b squared. So since b is 3, that'll be divided by 9. And then plus y minus my k squared. K is the y coordinate of the center, so that's 1. Divided by a squared. A is 5, so that'll be 25. And there we go. We got the equation of the ellipse that you would draw if you put your pegs in those two positions and use a string of length 10. So, that's a pretty good example.